Now the conclusions, well, now we know quite a lot about statistical testing, but the problem is that if we use several tests for the same sample, we increase a chance for making a type 1 error. So it means that we increase a chance, a probability to see an effect where this effect is fully random, okay? And if you want to tackle this problem, you can use different techniques. One of the techniques is a Bonferroni correction. It corrects the threshold. So for example, if you want to reject null hypothesis if p-value is smaller than a given, then the Bonferroni correction gives you this threshold to compare your p-value with, okay? And you can also use Bonferroni correction for confidence intervals. So just if you, for example, have 95% confidence interval, you need to take alpha and divide to the number of groups and use this alpha for getting, for example, t-values for the interval, okay? And then if you have all possible combinations, and then you want to compare means of the different combinations. If you have several grouping factors or one group with many different labels, then one of the best ways to do that is to use ANOVA. ANOVA tells you if you have any difference at all. And then Toki test, it complements ANOVA in order to see where is the difference and how big the difference is. And it's very important that every time you make a test, you always report a p-value and the confidence interval. The p-value allows you to say, do you see an effect or not? And confidence interval tells you how big the effect is, which even if p-value is very small, the effect can be also small. It's clear, but it's small, okay? You can't get any ideas about the size of effect by using p-values. If you want to see a size of effect, how big the difference is, you need to calculate the confidence interval. So that's always a good idea to show both p-value and confidence interval if you use statistical tests.